Thank you for taking the time to participate on this live broadcast. Next up is Robert Dahlstrom, CEO with Apellix, for a conversation on Are autonomous drones the future of the protective coatings industry? I'm Jim Kunkel, and welcome to the mid-season break episode of Coatings Talk. I have an awesome guest tonight. I have Bob Dahlstrom from Apellix. Bob, welcome.
Hi, thank you. Glad to be here.
Oh, it's great to have you. You and I have known each other for some time now, and it's great to have you on the live stream on an awesome topic. But before we get into our conversation about autonomous drones and their role really in the surface cleaning, and then also too when it comes to painting as well, we talk about that in the protective coatings industry. If you could do a favor and provide your background information, and also talk a little bit about your company so people get to know who you are, what you guys do.
Thank you. I appreciate that. So I guess one way to describe myself would be I'm a second founder of a company. So the first company I founded was a internet security software company. And to me, I'm in love with software. Software is what makes the world operate in my worldview. And so Apellix is a drone company, but I tell everybody it's a software company because to me, drones are flying computers. And if you're a computer, you're software. I mean, I've even heard like the iPhone been referred to as software wrapped in plastic because it's the software that makes this so valuable and so important and able to do what it's able to do. So prior to founding companies, I've been many things, everything from a butcher to a legislator legislator analyst. I wasn't a legislator themselves, but Mark Twain has a famous quote: "There are two things you never want to see being made: sausage and law." And I've done both. And then also a college professor prior to starting my software company. So I've got a lot of experience in different things. I grew up in my father's hardware store. So I have some mechanical experience there. My dad was an airline mechanic and a foreman. So, he kind of didn't understand software, but when I got into drones, he understood that. And so that was very, very wonderful to me personally to be able to share that experience with him. And Apellix, if you don't mind, I'll just tell the origin story.
Yeah.
I used to paint houses working my way through college. And my wife and I have a beach house that needed painting. And you drive under it, and then it's 2 stories, so it's pretty tall. And I had some time, my software company was doing well. And I'm like, oh, that's an expensive painting job because I got a couple bids. And I'm like, I can do this. I used to do this in college. Well, I had some scaffolding delivered and then had the ladder up on top of the scaffolding. And I'm up there painting. And very, very quickly, I realized I'm not in college anymore. So I'm like, there's got to be a better way. And I thought, well, drones. I could keep them with software the right distance from the wall to apply paint. But then I thought, no, that would never work. Paint is really heavy. Battery lives are limited. I'd have to be landing all the time. And I looked down, and that was the eureka moment. Because on the ground was the compressor, right? And I'm holding in my hand the spray wand. And I'm like, eureka. Keep the paint on the ground, the compressor on the ground, the power on the ground. Bring all those up to the drone, and then with software, control it and keep it the right distance from the wall. So I went home, built a prototype that actually worked better than I expected because I thought the propellers, spinning would just blow the paint everywhere and it wouldn't work. Worked much better than I expected. So then I kind of went heads down into developing the software development and developing the platform and starting the business from there. So it's been a exceedingly fun, transformational part of my life because this is something where I just have so much fun doing this. It's like I tell people I have the greatest job in the world because I'm playing with magical flying machines all day.
Yeah, think about it. You're going to have that joy, and then you also will eventually get to watch paint dry. So double the fun.
Exactly. Yeah. Well, and it's funny you mentioned that because, this whole world of painting, right? All I knew was what I did in college, which was spray paint houses and, put brushes and roll. I had no idea about the world of protective coatings. And there's a reason they call it protective coatings or coating system, not paint. Because unlike architectural and decorative paint, where you're painting a house to make it look nice and also protect it, The protective coating, you're putting, a very scientifically based system on a very expensive asset to ensure its viability to continue to operate. So it's a very important thing for our world and our society that people don't realize and people don't understand because they don't see things very often. They'll see infrastructure like a bridge when they drive over it. Very rarely will you see a dam, but not very people, unless you live in Houston, are going to be seeing, storage tank farms and oil refineries and all the rest of the things, even water and wastewater treatment facilities, all these things, maritime assets and ships, all these things that enable us to live the wonderful, comfortable, beautiful lives we have, the water that comes out on the tap, the toilets that flush, the air conditioning systems that run from electricity, all of this stuff, the gas in our cars, it's all hidden away from us. And protective coating is amazing because it's what keeps all this stuff running and functioning for a large part of it.
That's amazing. So, Bob, let me ask you this question. Do you know when the first drone was invented, and also, too, which country lays claim to that?
No, I don't.
Well, let me share this with you and everyone who's watching this episode. This is an Australian-made drone back when it used, I believe that would be 8mm camera. And from what I understand, that the camera video stabilization was horrible when it was in flight. And the other thing is it was very difficult on the landing, where it typically would result in damage to the drone and the camera system. So hats off to the Australians for trying to make the first drone.
I thought you were going to think maybe it was a stick.
Bob, when we look at where drones are right now, especially let's talk, because you've got things that do non-destructive testing, power cleaning or power washing, and then you have also too with spray painting. Drones that are going to be utilized in the protective coatings industry, where in the cycle are we? Is this like we're in the Model T years of the automotive industry kind of kicking off, or are we a little further along than that?
We're still in the really early days. And one thing I'll say about it is the spray painting drone, which everybody wants and loves, is still under development. And there's a reason why, because it's so exceedingly difficult. People say, well, why isn't self-driving car here? And I'll say, well, self-driving car in some respects, and people can argue the fact, but to me, a self-driving car is easy compared to a drone that flies and sprays paint. Because, you tell the self-driving car to stop and you can walk away from it. You can't let a drone stop and walk away from it. It's going to, gravity is always going to win. And the fact that you're having to have such fine precision, with cars or a lot of these drones, they have obstacle avoidance or distance hold or something that'll keep them from crashing into things. That's easy. Do something hard like the space shuttle, where the two space, vehicles merge and make contact. That's exceedingly difficult and hard to do. And that's what you're trying to do with non-destructive testing. That's what we've actually cracked that nut. So we can physically make contact with the surface with a drone that has a robotic probe tip on an arm sticking out of it. And then even harder is the coatings, because if you're trying to lay down, for example, 8 mils wet consistently, you have to be, depending on your different parameters, for example, you have to be 14 inches from the wall, moving at 0.6 of a meter per second. If you slow down or speed up, you're going to mess up that paint job. If you're too close or too far, you're going to mess up that paint job. If you're not perpendicular and you're tilted one way or the other, you're going to mess up that paint job, because 8 mils, that's thousandths of an inch. You're measuring these protective coatings in thousandths of an inch. So it's a very, very difficult thing that's never before been accomplished in aviation history. And it's the deep tech that we've done at Apellix that's enabled this to be able to do it. And right now, the development of spray painting drone is going well, but there's probably another 2 years before this thing hits the market. Non-destructive testing, that we've done, we're able to and by the way, the spray painting drone, and trust me, I've tried this, and I've had student interns that have flown for hundreds of hours to try this. You cannot paint manually with a spray painting drone. It's just too much. You have to have the computer do it, because by the time you see something and move the joysticks, for example, maybe in a second or a half a second, well, software, again, my love, software is making maybe 50 micro adjustments to the flight per second. It's something that people can't do. Any of the modern airplanes these days all fly by software, more or less. It's gone are the days for human pilots at this point. You're there to observe and to take over should something go wrong, but a lot of the aircraft these days are flown by software because it's just so much faster and often better and safer.
Yeah, and I could see where the software is super critically important, more so than the hardware. The drone itself is the vehicle, the method to the process or the procedure. If you're talking about non-destructive testing, the software, which is so amazing and important. And for you, you're able to really kind of program a painter inside that software to be able to perform, like you said, micro adjustments that are done in the milliseconds and things like that. And it's very difficult for a human to do these type of precision type of moves. Now, with the human interaction, there's going to be elements where humans could do some of the work, but the way I view the technology is that this is really a really nice opportunity where we have manpower shortages and worker shortages. We can prioritize what structures get painted with a drone, and then what would require human, or there could be a combination. So we have robotic abrasive blasting units now. You have the drones now that can do spray paint, power washing, and then also non-destructive testing and things like that for taking measurements. So it's a really kind of a neat melding of technology and human, and then the part with the software. Now, right before the broadcast, you and I were talking about AI. AI is a big topic. It's going to be everywhere in our lives. Do you see AI coming into drones such as what Apellix makes?
Oh, absolutely. And that's one of the great things about building a platform. So the Apellix drone basically is a platform to get something at elevation to do work, whether it's a spray wand to clean, whether it's a NDT device that you touch to a surface, or whether it's a spray painting wand to paint. It's just a platform. You still need that intelligence. And when you have a platform, then you have the ability to start adding things to it. And you add different types of cameras. Right now, you may have a visual camera for a good view for visual inspection, but then you can add a thermal camera. And now you can see things you can't see with the human eye, because you can see heat loss or different temperatures in the surface. And then you start adding things like artificial intelligence, right? Or machine learning, where potentially, and one of the standard bodies I'm working on with AMP, we're looking at just that, at AI and ML for detecting corrosion with videos. So, that is coming as well, and that's going to get better and better over time. But one of those great examples, I called this earlier software wrapped in plastic. The Apple engineers that designed this probably didn't think that, if you put your finger by the camera, you can actually shine the light through there and watch the blood course through the veins and get your pulse. But when you have a platform, it enables other things to be done with that platform, like AI and ML. And the perfect example of that is we had the U.S. Army approach us recently. They saw our spray painting drone under development, and when they decontaminate items, they use a compound that's almost identical to latex paint. And then they saw our power washing drone, and they came to us and they said, "Hey, we think with your tethered drones that can power wash and paint, we think we can reduce or eliminate the possibility of chemical or biological warfare." And we're like, how? That doesn't make any sense. But after going through this process with them, after them paying us to build a demo and to do all this stuff and learning about this, and this is all declassified, by the way. And one of the things is they want to start promoting this once we get further along, because of its ability to potentially reduce biological warfare. Is we've taken a process that right now, if chemical or biological agent was dropped on Army assets in the field, it degrades their ability to respond by 60%. And it takes them tens of hours to get back in service to where they're in fighting force again. We have come up with a way to do it with tethered drones that wash off the vehicle and then spray the decontaminant where it's needed, and it could be 10 minutes. So we've taken something that used to take tens of hours, could be done in 10 minutes. It's highly mobile. You can move it from location to location instead of now when they line them all up like in a car wash, and then that makes them a target to bomb from the air. And then also you do it from, a couple hundred yards or wherever, mile or two away, where the drone's over here operating, you're just pushing the buttons because it's doing all that autonomously. So once we get further along in that project with the Army, they're going to start promoting the fact that they have this capability now to respond so quickly that it negates the incentive to drop a biological or chemical weapon in the first place.
Wow. I would have never thought, drones, because you watch the movies where they use drones, killer drones and all these things with drones. But to think about how, it could absolutely be utilized to minimize the impact of a chemical attack, or maybe even a way kind of stop it, because it would be like pointless to do it because operational readiness could be 10 minutes or less with a drone versus, like you said, lining up all the vehicles and having a human go through the decontamination process. So that's amazing.
And it's one of those things that's absolutely horrible to do as a human, because you put on a full body suit and you're out there, on top of ladders or different things trying to get up on these structures. And then you have to turn and spray down the person next to you because you have to decontaminate the suit before you take the suit off. And, if you're in a hot environment in one of those things, it's just a horrible thing to do that much better to have a robot out there that can do that. Same thing in a lot of painting situations. If you're painting with, let's just say, a nanoparticle, for example, you can't filter that out with a respirator. You've got to wear a full body suit. So having painting drones or pressure washing drones that can spray chemicals and do surface prep, or even measurement drones that can measure things like flare stacks when they're live, all are applications that move workers from harm's way and put them safely on the ground out of the reach of danger. So that can't be understated, and that's one of the big benefits of a drone platform like what we've done at Apellix, is the additional safety that we bring to the industry.
So the next question I would have for you is regarding with ROI. If I am a industrial painting contractor, but I want to look at a drone, for example, that can, and I'm going to assume that if you're doing like tank washing, tank cleaning, you might have a crew of maybe 3 running the drone. Is that about right?
Probably. Usually we do 2.
2?
One person flying the drone, one person who's an observer, and also helping with umbilical cord management and keeping the pumps working and the chemicals flowing and all that stuff.
So if I have a drone like that and I'm doing, tank is a business, tank cleaning is going to be a business I want to, at this current stage with the technology, is the ROI there for the contractor?
It is. And
that's great to hear.
Yeah, we did a case study, and basically where we did half a tank with water, with a drone, where we cleaned it with a chemical, then washed it with water. We did the other half with people up on a lift doing the traditional way. And so the labor savings took about half as many people, 2 versus 4. Mm-hmm. And then also time savings, it took about half the time, 2 hours versus 4 hours. And then the big savings were in the fact that you didn't need a lift. So if you had to bring this equipment in to have a lift that people were up on to do the job. And then chemically, I think is about the same amount of chemicals were used. The drone might have used slightly more chemicals, but that amount is just kind of a rounding error. So the ROI there is pretty high, but where it makes it even higher are things like not too long ago, we did a cleaning of an above ground storage tank with a company that bought one of our drones. We were, because we're not a services company, we sell these drones.
Yes.
So we were helping them out, and this tank in Knoxville, Tennessee, was built into the side of a hill. So one side of it was 60 some feet tall. The other side was 30 some feet tall, because there was a 30-foot incline that this was built into. You could not clean that any other way. You could not get a lift in there and around that to put a person in a basket up there with a pressure washer to clean it. So that tank was exceedingly dirty because it had been 30 years probably since it had been cleaned. I mean, not only was there mold and mildew on there, but there was actually lichen, these little things with the roots grabbed onto that paint, was like grabbing in. So, we had one of the paint manufacturers take a look at it afterwards, and they're like, yeah, you probably extended the life of that coating by 3 to 5 years. And now if you look at this from the dollar point, right? So the municipality that owned that, it's not unusual for them to pay $750,000, for example, to do a painting system, a coating system on a very large tank like that, or an elevated water tower. Well, you say if it's a 30-year life, right? That's basically, it's cost $25,000 a year. So if you extended that life by 4 years, you save that municipality $100,000.
Yeah. Yeah, that's a great way to look at it. I wanted to ask that ROI because, the first thing I think a lot of people think of, it's great to have a drone and everything like that. I need to make money, but these things cost billions of dollars. And really, when you look at the ROI, what the investment is, you're really looking at there is currently great value out there to consider this as part of your business. And you've already sold drones and things like that.
Well, what's really, really interesting to me is, and I'm sorry for interrupting, but
No.
we've had a number of companies that are asset owners contact us and say, we want drones to clean these because we don't want to put people up in elevation anymore.
Yeah.
And the companies that actually do the job with the drones are able to charge a premium and charge more than the people that do it without a drone.
That makes a lot of sense. I'm sure everyone wants to see some videos. Bob, I know you have some videos. It's okay if I bring up your YouTube channel now?
Oh, absolutely. Please.
All right. So we got some videos here. Bob, is there any particular one we want to start with?
You just take your pick. It really doesn't matter. They're all fun. And there's a story behind each one of them.
Let's do this one. Let's do this first one here, which is with the power washing with tethered.
Yeah, so this drone, this is that tank I was talking about in Knoxville, Tennessee. So this drone is battery powered. So it's our B1 version, B for battery. Our X1 version is our powered from the ground version, where you've got a 230 volt, 50 amp circuit you plug into, or you plug it into a generator. So there's advantages and disadvantages for both. Advantages of the battery is it's more mobile. It's easy to get there without having to lug a generator around with you in case you don't have ground power. The advantage for grabbing ground power is you can stay up theoretically all day without having to land and swap batteries.
Yeah.
The battery one, again, this was only 60 feet at 65 feet, something on the maybe 68 on the tallest portion of it. So we were getting 20, 25 minutes of battery time when we'd land, which actually is kind of nice because it gives the pilot time to like relax their neck for a little bit. But yeah, the drone would fly up and they'd spray the chemical, go up. I think we did about a third of the tank with the chemical. Then we came back and did the rinse because the chemical has to dwell on the surface for a certain amount of time to kill all that biological growth that's on there.
Yeah, Bob, I don't know. Can you still hear me?
I can, yeah. We didn't see the video, or I didn't see the video.
Yeah, my computer is locked up on me right now. At least I can talk. I apologize, everybody. I'm sorry. I thought I could get this to work tonight, but for some reason, the computer is giving me a hard time.
See, if I could blame it on me in Florida because we had a huge rainstorm come through, and of course the lights flickered and all that stuff.
Yeah,
but yeah. That's already passed. That happened earlier today.
Yeah, I'm kind of, let's see what happens here. I'm trying to get this thing to respond to me. So, but let's see what else we can talk about. We talked about the regarding power washing, spray painting, a little bit non-destructive testing. Get some weird screens now. There we are. We're back. Can you still hear me?
Yes, we can. Yep.
Oh.
Yeah. So the the one way of looking at that is that there are three products. We started with the hardest one, the spray painting drone, which still isn't at the market. Still got a couple of years of development to go. Right now, there are many things it does better than a human, but there's certain things like lining up a stripe so it matches perfectly for 50% overlap for the next stripe that a human does better than our machine. But the power wash drone works awesome. It does some limited surface prep. So you can do SSPC, SP1, removal of visible and non-visible contaminants or degreasing, to clean a surface prior to coating it. As we develop that platform, there are two things we want to do is add the autonomy to it so it's not manually flown. And then also increase what we're able to get out of that, because we can get 3,000 psi at a flow rate of 8 to 10 gallons per minute. And when you're doing these large industrial structures, that flow rate is critical, because you need a large volume of chemicals and water to be able to clean these things off, especially water, so that the biological growth that was on there sheets down and sheets off. And then the measurement drone. But those three platforms, the painting, the measurement, the cleaning, all fit into one sort of overarching philosophy, which is corrosion control, right? So the coatings industry. So we want to take the spray painting drone when an asset's new, paint it. Over time, take the measurement drone and be able to measure the thickness of the paint, maybe even measure the thickness of the asset to make sure, it's still viable. Over time, take that cleaning drone and pressure wash and keep that asset clean. And then when needed, be able to potentially do some blasting and coating of certain sections, and then eventually do the whole tank. So sort of cradle to grave asset life cycle management with drones for the maintenance of the asset.
Wow, that's amazing. Bob, in closing out this episode, is there anything that we didn't talk about that you would want to cover, or is there anything that you could preview potentially of what you got in the works?
Not really. I already told everybody about the U.S. Army thing. We have something with another company that we're not at liberty to disclose, but there's just so much interest from the industry. We're in a very fortunate position to have this technology and to be the forefront leader in this, that we have people constantly contacting us from around the world daily with various use cases, like the Army did for the extending the platform, to particular jobs that they have. And one of the things we constantly have to do, though, is pull people back to reality, because they see, some of our videos of the spray painting drone doing a wall, and they're like, oh, if you can do that, then you can do this really complicated hard thing over here. And no, we can't. So you have to walk, you have to crawl, then walk, and then run. And so we're constantly saying, okay, come back. Here's what we can do now. Spray painting drone is only for flat vertical surfaces like walls or above ground storage tanks or ship's hulls. It's not going to do anything complicated anytime soon. We have to perfect that before we can start adding things to it. But the opposite is true basically when it comes to non-destructive testing, because right now we've partnered with Dahlstrom for the dry film thickness, and we partnered with Olympus for the ultrasonic thickness for wall thickness. Those are the two companies that make the handheld devices that people are currently using, and that ties into our existing computer, because we've got an API from them where we stream all that down live to the operator. But if we wanted to change out that device that took a measurement with another device, we don't have to change the precision flight control at all. So the software is already written to do that precision flight control, to allow that drone to make physical contact with the structure. Doesn't really care if there's a DFT or a UT or some other type of measurement sensor that's on there. And then, of course, you're taking physical contact measurements, but you've also got a camera on the drone, right? So there's all your visual inspection data at the same place. There's all your data that can be used for AI and ML and all the different things for non-destructive testing 4.0.
Oh, that's amazing. Wow. What an awesome topic to cover. And how can people get in contact with you or stay connected, follow some of these advancements that you have coming out?
Yeah, so there's the YouTube channel, but there's also our webpage. So the website is apellix.com, APELLIX.com. And there's a page on there called Apellix at Work, which was the page you brought up, Jim, which has all the different videos of some of the things, some of the projects that we've done. So that you feel free to go there. And then, of course, there's the social media links that you can follow us at.
Wonderful, wonderful. And everyone, just so everyone knows, the Coding Stock live stream, this is going to be a mid-season break. It's summer, coming into summer in North America. So usually what I find last year and years prior when I do streams during the summer in North America, it's usually not a lot of views. I will still continue putting out Coding Stock videos and other video and content as well during the summer, but the live streams will be starting back up in September. So look forward to that coming up. And I'd greatly appreciate everybody could check out the Cuttings Talk channel, become a subscriber. Also to follow me on LinkedIn. And I so greatly appreciate all the supporters and all the subscribers. Everyone is just absolutely amazing. You encourage me and really drive me to do better and be better. So thank you very much. Bob, thank you for an awesome conversation this evening.
No, thank you, Jim. It was great. I enjoyed it. I hope I didn't drone on too long.
Well, no, I wish I could have shown the videos of the drones, but maybe that's an excuse for you and I to get back together again, and in the fall.
Exactly, especially with the digital part, because there's a lot of this, and one of the things we say around here all the time is it's all about the data. Yeah. Because and that's one of the great things that people love about the painting drone, which is still under development, is right now there's all this paint that's applied that nobody knows how it's applied. And if there's a paint failure, the paint company says, oh, the applicator put it on wrong. But the applicator says, oh, the formulation was bad for the coating. But the drone can tell you relative humidity, ambient temperature, barometric pressure, temperature of the surface that was being painted, speed the drone was moving at, the tip, the flow rate, all this stuff that creates a digitable, auditable record that can then, because I'm guilty of this myself. I've been out there painting before and I'm like, oh, it's getting late, it's getting dark, it's humid. I'm just going to finish this up. And I painted. Next day, I was out there with the pressure washer cleaning it off where it had slid down off the building and made a mess.
Yeah, you're right about that. All right, Bob, thank you so much. Everyone have a good rest of your evening, good morning, or good afternoon, no matter where you're watching this in the world. Thank you so much.
Thank you, Jim. I appreciate it so much. Thank you.
Thank you.